Hey guys, welcome in this first episode of Bitsletters. It's a new series of videos where I will talk about subjects that I like the most. So you can expect artificial intelligence, data science, computer graphics, web development, and many more. I will present you news around those topics, new tools, and interesting research papers. I hope you'll enjoy it. Good news for PyTorch fans, we get a new release, the version 1.11. This new version brings three main highlights. First, torch data. If you're a PyTorch user, you probably use data loaders and datasets from the PyTorch data utils to build your data pipelines. However, it has some problems. The data loader is monolithic, so it has a lot of features built inside, and it's really difficult to extract some part of your data utilities to reuse them in other data loading pipelines. In machine learning, we tend to have low data utility primitives that we reuse for different use cases. For instance, we might load a file from the disk, cache some operation, shuffle the dataset, batch the dataset, and it would be nice to have all those components developed separately so we can combine them as we wish in our data pipelines. It's precisely where Torch Data comes to help. It is a library of many low primitives for data utilities that you can compose to build your own data pipelines. It has already around 50 of them, and you can even develop your own to face any situation you might encounter in your different machine learning problems. I think it's a step in the right direction. It reminds me a bit of TensorFlow data, where you can easily build pipelines for your datasets, combining different primitive operations like shuffling, caching, batching, and I kind of missed this feature in PyTorch, but now we have it. The second highlight from PyTorch version 1.11 is the introduction in beta of FunTorch. It is heavily inspired from the Google JAX library, if you know it. FunTorch adds composable transforms to PyTorch, like grad, vmap, or Hessian. The idea is simple. You build a simple Python function, no need of classes or modules. Then you apply a transform to it, and you get nice features. For instance, the vmap transform. You can write any function in Python using APIs from PyTorch that process one element at a time. Then, calling the vmap transform, it will change the function to be parallelized over the batch dimension. You also have the grad transform. Write any function in Python processing some input with PyTorch API and apply the gradient transform to it. You will get the gradient from the function. Or the Hessian transform. So write any function in Python using some PyTorch APIs, apply the Hessian transform, and you will get the Hessian from your function. Good thing is that you can compose those transforms. So for instance, if you want the second order gradient, you can just apply 2 times the gradient transform over your function, and you will get the second order gradient. It is particularly useful when dealing with complex cases in PyTorch. For instance, computing the per sample gradient in vanilla PyTorch can be difficult. However, using the grad transform from the FunTorch API makes it easy. We are going to explore the different use cases from FunTorch in further videos, so stay tuned. The last feature from this new release is the distributed data parallel static graph optimization. PyTorch has great distributed capabilities thanks to the distributed data parallel container. The container parallelizes the execution of a module in PyTorch across different devices by splitting the input over the batch dimension and sending those chunks to the different device. The static graph mode brings some optimization. It assumes that you use the same set of used and unused parameters at every iteration. Doing so, it can deterministically determine the states of your training, like which hooks fires or not, or the order of the gradients, and so on. Then it applies some optimization, like avoiding to search in the graph for unused parameters at every iteration. For some recommender systems, it brought a 10% improvement in the number of queries per second, or QPS. Another great news for PyTorch fan, we get a new PyTorch Lightning version, the 1.6. I will also present you 3 main highlights of this new version, but I encourage you to look at the release on GitHub and see all the new features. The first highlight of this new release is the support for Intel's Habana accelerator. If you don't know about Habana, it's a lab founded in 2016 to build new world-class processors to train deep neural networks. Habana released Gaudi, the first AI processor with 10 100GB ROCE ports. Those ROCE ports delivers lower latency, lower CPU load, and a higher bandwidth. This is crucial when training in a cluster with many different nodes and leveraging distributed parallelized computing. This is a great news that PyTorch and PyTorch Lightning are now supporting those new kind of accelerator. The second highlight from this version is the Bagua strategy. Distributed training is getting more and more important as we are training bigger models on bigger datasets. The Bagua strategy implements different advanced algorithms for distributed training. For instance, the all-reduce strategy for synchronous centralized communication, where the gradient is average over all the workers. You also have the decentralized SGD, for decentralized communication between workers when one worker might exchange data with one worker or a few specific ones. The Bagua strategy contains many more techniques that you can use for distributed training, and I encourage you to look those in the documentation. Indeed, using those advanced distributed training strategies can help you reduce significantly the time you spend training your models. The third highlight of this new release is the refactoring of many APIs in the framework. PyTorch Lightning provides many different APIs to extend its functionalities, like accelerator, strategy, and the plugin API. It's in part what makes it such a great framework. This release brings large changes to improve the APIs and framework overall experience. For instance, all the training type plugin has been renamed to strategy. Also, the accelerator and the precision plugin API are now moved to strategy. I encourage you to take a look at the release on GitHub to have an idea of all the new features and all the new experimental features available in this release. If you are interested in computer-generated or assisted art, you must check the new OpenAI model called DALL-E 2. DALL-E is a model from OpenAI released in 2021 originally. It's a version of GPT-3 with 12 billion parameters trained to generate images based on text descriptions. And it has awesome capabilities, like creating realistic or artistic images based on a text description. You can also make realistic edits to an existing image based on a natural language caption. It can also add and remove elements, taking into account textures, reflections, and shadows. Finally, it can take images and generate a variation of it inspired from the original. I'm a huge fan of computer-assisted or generated art, and it's an awesome tool for digital artists. The ability to control it with natural language makes it easy to use for everybody. It's also easier to express complex nuances when using natural language processing instead of tweaking a bunch of settings when manipulating images. I want to introduce you to an interesting research paper called Gradient Without Backpropagation. Deep learning relies on the fact that we can compute easily the gradient of complex functions using well-designed libraries like PyTorch or TensorFlow. This gradient computation is achieved via automatic differentiation. The majority of implementation leverage the backward mode of automatic differentiation. It's a forward-backward algorithms working in two passes. First, the forward pass from the input to the output. Then, the backward pass from the output, and we get the gradient of all the weights of our model. It is well known as the backpropagation algorithm in the machine learning community. However, the reverse mode is only one member of a bigger family of automatic differentiation algorithms. The paper introduces a new technique. They call it the forward gradient. It's an automatic differentiation algorithm leveraging the forward mode. The forward mode presents the compelling advantage of requiring only one pass, the forward pass. Doing so, it decreases the complexity of the training algorithms, improving the speed and the energy consumption of the training. Comparing this new technique with the traditional backpropagation, they managed to get up to 2 times faster. This is a really interesting result, showing that we can train our current neural network architectures using only the forward mode. This allows to train a model faster or to build even more complex models for the same computational budget. Check out the paper if you are interested. I put the link in the description. For the last subject of this first episode, we leave AI to talk about web development. And we have a big news. React is releasing a new major version, React 18. If you don't know it, React is Facebook, or now Meta, open source and super popular framework to build interactive UIs. This new version brings new important features to the library. First and foremost, the concurrent mode, which allows React to interrupt UI updates in the middle of the rendering process. Before this mode, all updates happen synchronously without any possibility of interruption. Now React may start rendering an update, pause in the middle, come back to it later, or even completely abandon the given update. With this new capability, React can start preparing screens in the background without blocking the main thread. For instance, the UI can respond immediately to user inputs, even if a huge update is being rendered. It improves the user experience considerably. Another great feature is auto-batching. Batching happens when React groups multiple state updates into one render to increase the performance of your application. Before this update, React could only batch the updates inside React event handlers. Now React is batching updates inside promises, set timeout, or even other places where it wasn't possible before. Lastly, I will briefly talk about the transition feature. It's a new concept in React, which allows us to tell whether an update is urgent or non-urgent. If we think about it, the urgent updates in our applications are, for instance, when a user is clicking, typing something, pressing a key, so direct interactions. On the other side, we have transition updates, which are non-urgent. This happens when the UI is moving from one view to another. By differentiating those two kinds of updates, React can prioritize the urgent one, leading to an improved performance and improved user experience. It was a high-level overview of this new React 18 version. But you can check the release notes on the GitHub of React or their blog. I will put the link in the description of the video.
you.